Hey everyone, welcome to TechBrick YouTube channel. This is Arjun. Today we are going to cover the continuation part of functions, and we are going to discuss on two topics. One is closures and another one is recursions in Golang. So if any of you not yet watched my previous videos related to functions, I would recommend you to watch it. So let's get started. Now let's try to understand what is closure. Closure is a function value that references variables from outside of its body and anonymous functions that helps us to form the closures. So we'll try to understand both of these points with some example. So let's try to define one function. So let's say like function, we will name it as a closure function, and here we will have a return type as function, which takes no parameter and returns integer. And we will take some like local variable, like let's say like initial value is equal to 0, and we need to return that function, right? So let's return. So what we will do here, we will increment this initial value by 1 and we will simply return. So let's try to understand what exactly here we are doing. So this is a one closure function, I mean one normal function we have taken, which is taking no parameters, and the return type is again a function which is taking no parameters and returning integer. So that is fine. Now we have declared a one local variable, I mean like declared an initialized, so initial value, and that we have kept it as 0, and we are returning a function, right? So we need to return. So we are returning here by incrementing this one, and we are actually returning that initial value. And if you see the second point, anonymous function that helps us to form closure. So here, this line number 12 to line number 15, this is the anonymous function. So which we have already discussed in my previous video. So anonymous function is a function which is having no name. So here we are not specifying any name to this particular piece of code, that is line number 12 to 15. So this particular piece of code, we call it as the anonymous function. So anonymous function which helps us to form the closure. So here we have written like a closure function. So this is fine. Now we will come back to main and we will try to understand the first point as well. So let's take like a function 1 and we will call closure function. Okay. So now what we will do, we will simply try to print it. So let's say like the number is function 1. And let's try to run it. Let's see what exactly it gives. So yeah, it is giving number 1, and that is expected because as soon as we are calling closure function, so initial value is 0 and we are incrementing and we are returning the same value. So that's the reason it is actually 1. So now what we will do, we will try to copy the same one and we will try to execute it again. So now, like in usual scenario, what is expected? So now also, again, it should call this one and again initial value is 0 and it should again return like 1 itself. So that is what we should print, like number is 1 and again number is 1. So let's see like what exactly it does. So if you observe, number is not 1 in the second iteration, I mean at the line number 12. So what should be the reason? So in ideal scenario, we know like whenever we are declaring any variables in any of the function, that will be acting as a local variable for that particular function. And as soon as we return or like complete the execution of that particular piece of code or piece of code which is present in a particular function, then whatever the local variables which we have created will be flushed, unless if it is a pointer. So like it will be remain, otherwise it will be flushed, I mean it will be cleaned as soon as it completes the execution of that closure function, or like whatever the function, and the local variables will be flushed. So but here initial value is a local variable, so obviously as soon as it executes line number 21, so it should be flushed, right? So but what exactly it is doing here? So that is where we discuss about the first point, that is a closure is a function value that references the variables from outside of its body, nothing but here also somehow we are getting the access of this like initial value. That is why we are like fetching like as soon as we are calling line number 12, so instead of initial value to be 0, it is 1, because initial value is not flushed. And closure function, what exactly it does, so whatever the variables which are there in closure functions which will be not, I mean those will not be cleaned whenever like even if even after like completing the execution of a closure function. So that is what exactly happening here. So here actually it's not actually cleaning. So if I simply call it again, right? So now also it should like print like number 1, number 2, and I mean number is 1, number is 2, and number is 3. So that is fine. And now if I create like one more function, function 2, and if I call this one again, now like any idea like what exactly it may give? So obviously like people will be thinking like it should like again have like what do I say? Like it should like again have 4 or something, but that is not how it is. So here it should again, because we are calling it again, right? So it is like going to create a new instance kind altogether. So that is why it is again printing number is 1. But instead of this one again, if I call function 1, then again obviously it will be like having the initial value which is something else. So it will be like after this one, if I had it again, so obviously 1 2 3, so then the number will be 4 in the next iteration. So here actually we are again separately we are calling this closure function. So this function 2 and function 1 both will have separate initial values. I mean, both will be stored in separate stacks altogether in a memory. So that is where like both are differing. So this is with respect to closure functions. So now we will try to understand like recursions as well. So recursion is nothing but a function which calls itself. So nothing but like when we have like, so let's say like we have a one function f1, and while defining that function f1 we will call the function f1 itself. So that is what the recursion. So we'll try to see with some example. So let's have a one function, a basic example, a one classic example for explaining, that is finding a factorial. So factorial, and what we will do here, we will take integer as an input and we will return integer. So factorial, like if like a number is 0, then like n 0 factorial is 1, right? So we will return 1. This is like a handling corner cases. Then what we will do here, return n into factorial of n minus 1. Nothing but, so if you are finding like a 3 factorial, 3 into 2 factorial. That is what we do, right? Then again, 3 into 2 into 1 factorial. Then 3 into 2 into 1 factorial, then 3 into 2 into 1 into 0 factorial. So 0 factorial value we already know, that is 1. So 3 into 2 into 1 into 1. So nothing but that is how we calculate the factorial. So we have written this function, and this is the recursive function. So if you observe the symbol as well, so this like says like this is the recursive call actually which is happening here. So this is the function and the function which is calling itself. So here we are again calling the same function. So this is what the recursive function. So let's try to call this one. So for now, let's comment this piece of code. Now we will try to call the recursive function. So factorial of, let's say 5. Uh, we are returning, right? So let's try to print this. So factorial is, so let's have one more break. Cool. So let's clear the screen and let's try to run it. Okay, factorial is 120. So the 5 factorial is 120. So that is working fine as expected. Now we will try to, instead of like writing a function outside, so we will try to have a like anonymous function here, something like kind of a closure altogether. So what we will do here, we will have something like a factorial, and what we will do here, function which takes n as an integer and which returns, and the same piece of code will copy. Okay, so now what we need to do, using this variable we need to call that fact of 5. Okay, so now like whatever the parameter we pass, that will be passed to this function. So this is like almost similar to like immediate yeah, I mean like immediately invoking kind. So let's see what exactly it does. So let's have like here again like a fact is something like the some print statement will give. Let's try to run it. Okay, this is also giving 120, so working as expected. So this is like a kind of like anonymous function, or not an anonymous function because we are giving some kind of a name. So this is almost similar to how we are actually doing it. So whatever the factorial name we have given, so that is what actually here we are taking it as kind of a one variable altogether kind. I mean, this is of type function. This is what the type of this variable FAC. So this is how actually we can deal with the recursion functions or like a function which calls itself. Okay, cool. Now let's try to understand one real-time usage of closure functions. So if you look at the example, so here what exactly we are trying. So whenever we are trying to hit any like a URL, so let's say like you are like trying to hit like any like Facebook or like any Google like any of the URLs. So like a google.com or like facebook.com, so or amazon.com or any other URL. So we will be like trying to make sure that like we will be having some predefined like retries, because if due to some network issues like we are not able to hit properly, then obviously we will be keep on retrying, right? So that is what actually we are trying here, so using closure functions. So if you look at line number 45 to 54, this is the closure function. So what exactly we are doing? So one call API we have, so which is having a return type, that is a function which takes parameter as n, and return type is like a bool and integer, and we have a one retry count, and here we are actually a piece of code. This is anonymous function. So what exactly we are doing? So here we are actually incrementing the counter, because this particular piece of code you can like ignore, because instead of hitting the actual like URL, so we are simply trying something, and like based on that one like we are like performing increasing the retry count, also checking some case as well. So here actually we are like giving some number as an input, and we are trying to find the random number by first like identifying the source based on like time, like current time, and then like we are identifying like some like random, and then again like integer, we are dealing with integer. So like we are actually randomly getting some number, and if the number is greater than one, whatever the number we get it, the random number, so if it is greater than one, then we will say it as the API is successfully we are able to hit. If it is less than one, then like due to some network issue or something happened and we are not able to hit the URL properly. So that is what like actually we can think of now. And the retrieve count is nothing but like again, so whatever how many times we have retrieved. So just now we have discussed like this will be keep on like incrementing, even though we are like initializing like a retry count as 0, but because it will be keep on calling this one. So if you come to main, so here we are calling and we have like set like some maximum retry. So after like doing these many retries, what we will do, we will simply like break this for loop. So here if it is an infinite for loop, so this particular piece is an infinite for loop. As soon as we get any of these two conditions, like either like we got like status as this one, I mean successful status, or maybe this whatever the count like whatever we have. So if it is like already reached the maximum attempts, then only we'll break this by printing whatever the like a status on the count. So this is with respect to this one, and here we are passing the n as 3 in order to identify the random number. So let's try to run it and we'll try to see like how exactly it behaves. So go run main.go. So if you see here, true to nothing but in the second attempt it got success, and that is why it is true. And so and it is breaking. So it's not like always it will be in the second iteration only we will be getting this one. So if I run it, so it is in the first iteration it got, and if I run it again, it is in the third. If I run it again, it will be two. So it will be completely like random. So it may be in like different iterations, we will get like a different number. So it is almost like similar, like whenever we hit any of the URL, so we will not be like 100% sure like we will be getting a successful all the time. So sometime due to some network issue, we will not be able to hit the URL properly. So that is where like we have to retry. So we will be defining some set of like maximum retries attempts. So till we reach that maximum attempt, so we will be keep on trying to hit that URL. So as soon as we reach like maximum retry and still we are not able to successfully hit the URL, then we can say it as that particular like URL or like whatever the server might be down or due to some reason, or maybe a lot of network issues might be happening. So unless we reach maximum like attempts, so we will be like keep on retrying. So this is one of the classic example where we use the closures, because whatever the retry count we are using, right? So this will be like nowhere like a main function, I mean whoever the client, so they will not get to know what exactly here we are doing. So everything will be handled by using like closure function, and here anyway like every single time, so it will be keep on incrementing. So and if I simply run this one again, right? So again it will like act as a altogether, like it will start like a separate instance or separate like iteration altogether. So something like when you are trying to hit like a Google URL, and again when you are trying to hit like Facebook URL, so separately it is going to create like a retry count, like a two stacks will be created for like a Facebook URL as well as Google URL, let's say, and a separate retry count variable will be put it into stack memory for both of those Facebook URL as well as the Google URL. So both will be different, and whenever they got success, whatever the count, so the respective count will be different. So obviously it depends on like the success. I mean, whenever we will be hitting the URL successfully. So this is one of the classic example where we apply like closure. So that is like whenever we are like performing retry mechanism. So yeah, this is with respect to closure. So if you guys have any doubts, please comment it out. I would love to answer all of your queries. And also, if you guys like this video, please do like, share, and subscribe, and also hit the bell icon to never miss an update. Thank you.